Hello, my name is Jessica Perry, and for my final project, I'll be focusing on mental health in tech. My topic brings to light how mental health challenges are increasingly common in the tech industry. I got inspiration for this project when working on my capstone related to mental health and AI. I wanted to further explore mental health and decided to choose the tech industry for this project. I recognize that tech workers face high stress, burnout, and numerous stigmas around mental health, especially when trying to reach out and work towards getting help. This project uses survey data and machine learning to understand which factors influence whether employees reach out for mental health treatment. I use the mental health in tech survey dataset from Kaggle. The dataset comes from a 2014 survey conducted by open sourcing mental illness, an organization focused on understanding mental health experiences in the tech industry. The survey collects self-reported responses from people working across different tech roles. It includes demographic information, workplace culture indicators, mental health history, and questions about how mental health affects their work. The key features include work interference, employer benefits, family history, supervisor support, and remote work flexibility. My target variable is whether the respondent seeks mental health treatment, labeled as yes or no. After cleaning the data and applying encoding to the categorical variables, I ended up with 25 usable features for machine learning and 1,259 records. The question that I started with and later turned into a problem statement was, can we predict whether a tech employee will seek mental health treatment based on workplace factors, demographics, and employee support? This is a supervised learning problem and specifically a binary classification task, considering yes and no responses from the target variable on getting treatment. I believe understanding these patterns can help organizations work towards designing better mental health support systems. For the methods, I used a range of machine learning methods that each bring a different strength to understanding treatment seeking behavior. I didn't want to rely on just one model because mental health decisions are influenced by a mix of personal history, workplace culture, and social factors. Using multiple models helped me see the problem from different perspectives and validate the patterns I was finding. I started with a logistic regression because it's simple and it gave me a good baseline to understand the data. It helped me see how different features relate to the likelihood of someone seeking treatment, so it was a good starting point. After that, I added KNN, which is a similarity based model, and even though it didn't perform the best, it was useful to see how a distance based method handles this kind of high dimensional, mostly categorical data set. Then I moved on to decision trees and random forests. Decision trees are helpful because they show clear rule-based splits and reveal nonlinear patterns. Random forests take that idea further by combining many trees, which makes the prediction more stable and reduces overfitting. They also give columns importance scores, which really help me understand what factors matter most in predicting treatment-seeking behavior. I also included a support vector machine, which ended up being my best performing model. SVMs are really good at finding the optimal boundary between classes, especially once everything is encoded. Finally, I used a neural network to capture deeper interactions between features, and I added k-means clustering to explore natural groupings in the data without using the target variable. I believe this helped me see whether people with similar workplace experiences or mental health histories tended to cluster together, which supported the patterns I was seeing in the supervised models. Now, moving on to results and insights, it seems that all six models performed pretty consistently with accuracy scores clustered between 0.79 and 0.81, starting from the beginning though. I first started by exploring the data and looking into age distribution of respondents, gender representation, and employer benefits versus treatment. The age distribution showed that most respondents were between their mid-20s and mid-30s. The gender representation, which will be shown in the upcoming slides, was heavily skewed toward men. The most important early insight came from looking at employer benefits versus treatment. People who reported having mental health benefits at work were noticeably more likely to seek treatment. That was one of the first signs that workplace culture and support systems play a major role in whether someone feels comfortable getting help. The correlation heat map here shows that the features in the top left corner, called work interfere sometimes and family history yes, are somewhat related to the treatment feature. You can also see the positive correlation between wellness programs and the correlation between seeking help, especially through the colors that are not blue. This treatment seeking distribution chart shows how the treatment variable is divided within the dataset, revealing nearly equal numbers of yes and no responses. When also considering the gender disparity, it suggests that about half or possibly fewer respondents seek treatment, which raises the question of whether the rate might be even lower in reality than what is captured in the survey. Once I had a good understanding of the data, I trained several machine learning models using a 80-20 train test split to see how well I could predict treatment seeking behavior. This logistic regression hit around 0.80 accuracy. It had strong recall for treatment seekers, which reinforced that the patterns in the data are pretty consistent. The KNN was the weakest model at around 0.76 accuracy, which makes sense because KNN struggles with high-dimensional encoded data, but it was still useful as a comparison point. The decision tree and neural network models also had an accuracy of 0.80 for both, and strong recalls for people who do seek treatment. The decision tree has a recall of 92%, and the neural network has a recall of 85%. Random forest performed really well with about a 0.80 accuracy, and it was the most balanced model overall. It correctly identified 73% of non-treatment cases and 88% of treatment cases. Random Forest also gave me feature importance scores, which helped me understand what factors were actually driving the predictions. The feature work interfere sometimes was also prominent in the correlated heat map. My best performing model was the sport vector machine with an accuracy of 0.81. But what really made SVM stand out was the recall and precision. It had a 93% recall for people who do seek treatment, meaning it really missed someone who actually got help. And it had 92% precision for people who don't seek treatment, meaning it didn't mislabel many people either. It seems to show that SVM found a really strong boundary between the two groups. I also looked at k-means clustering to see if people naturally group together without using the treatment label. One cluster had a much higher number of treatment seekers, while the other two leaned more towards non-treatment, and it seems to show that the underlying patterns are strong enough that people with similar experiences tend to fall into similar groups. As an information manager, there are a few important things that I would like to bring up for the final takeaways. The dataset is heavily skewed toward men, which means the experiences of women and non-binary or other individuals aren't fully represented. And the self-reported nature of the survey introduces potential cultural and reporting biases. Even with these limitations, using the data, the models consistently showed that workplace culture and support systems matter more than demographics. Reaching about 80% accuracy is predicting treatment-seeking behavior. In the end, the answer to my problem statement is yes, we can predict treatment-seeking behavior, and the insights point directly to areas where organizations can make meaningful changes to support their employees' mental health. Thank you.